Hi dear students, this is Vetri. In this video we are going to see about graphs. In nonlinear data structures, I already explained that we are having two different categories. The first category is tree and the another one is graph. Okay, so in here we are going to see what are the different types of graphs we are having and how we are going to deal this nonlinear data structure, how that operations and things are working out. Okay, see, first let me explain what is graph. Graph is a combination or collection of edges and vertices, right? Graph is a combination of non-empty sets of vertices as well as non-empty sets of edges. See, usually we know that we used to call a node in tree, right? An element as node, but here we are going to call as vertices. Okay, see, vertices 1 v1 and v2, and here there is no connection between these two vertices, these two nodes, right? So they definitely it's not a graph. When we are having an edge between these two vertices, so definitely we used to call this as a graph. Okay, graph is a collection of, we can name it h1. Okay, so graph is a collection of vertices as well as edges. Okay, if we having one more, vertices means, see how many number of edges would be there. So there are 3 edges. So here I am going to represent the graph as, so already I have told that G, which is nothing but graph. Graph is a collection of non-empty sets of vertices as well as edges. Okay, see, into that v1, v2, v3 and comma e1, e2 and e3. Okay, so simple, the definition is very simple and logic also very simple. Graph is a collection of non-empty sets of vertices and edges. Okay, so let me explain what are the different types of graphs we are having and what are the representations are available. Okay, so here we are having two different types of graphs. Okay, the first one is directed graph and another one is undirected graph. From the name itself we can understand that. So there will be direction in directed graph and there will not be any direction in undirected graphs. See, for the diagram, v1, v2, v3, v4. So the names are nominated as, so we can use any name, okay, for the vertices. And see, it's a graph, right? See, there is no direction on between these vertices, right? See, and if you are having a direction between these edges, these vertices, means we used to call this graph as directed graph. If there is no direction, so it's going to be undirected graphs. So we are having some methods to traversal the tree, to traversal in graphs. Okay, we'll see that about that in next video. And now let me explain how to represent this kind of graphs in nonlinear data structures. See, here we are having two different types of representation. The first one is matrix based representation and another one is list based representation. Here, so these are the two type of representations available. Okay, the first one is adjacency matrix representation and adjacency list representation. So first we will see about adjacency matrix representation. So by using the graph, I'm going to make one adjacency matrix. So we know that, right? The logic is, if you are having an edge between two node means, so we have to represent a matrix value as 1. If there is no edge between two vertices means, so we have to represent the matrix value as 0. Okay, see, So I am going to take the matrix as G So how many nodes? V1, V2, V3, V4. V1, V2, V3, V4. Right? So definitely diagonal will be 0 for this graph, because don't know isolated edges. Okay. Next, from V1 to V2 we are having an edge, right? And from V1 to V3 we are having the edge, but for V4 there is no edge between V1 and V4, right? So by using the same logic, for V2 to V1, yes, we are having the edge. For V3, no edge. For V4, we are having. From V3, we are having connection to V1 and V4. So there is no connection between V3 and V2. Okay. Next, from V4, see, we are having connection between V2 and V3. So that's it. So here I have made a matrix, adjacency matrix, by using this graph, and it's an undirected graph, right? In some case there will be if we are going to create adjacency matrix for directed graph, means so we have to represent by based on the direction. Okay, for example, if you are having a direction like this, okay, see, from V1 to, so it's quite similar, right? V1 we are having two connection, outgoing connection, so which is V1 and V3, and from V2, see, we have only one connection which is outgoing, it's going out, it's an outgoing direction, right? Only for V4, not to V1, so there is no connection between V1 and V2, right? From the point of V2, right? So similarly we can make it that, and from V3 we are having only connection to V4, and from V4 there is no connection to other adjacent nodes, so we have to keep 0 for all other, for the particular row. Okay, so that's it. This is how we are going to make adjacency matrix for representing the graph. Okay, so let me explain about adjacency list representation. Next, so here we are going to represent the graph by using list. So here we have two methods. Okay, one is based on a list and another one is based on array. Okay, so we can represent the list by using both these methods. So first let me explain with list. Okay, see, you have to take the head nodes of, first we have to find out all the connections. Okay, so from the graph A, so definitely for single linked list we will be having two fields, right? And A is having connection to B, and from B there is a connection to D, and from D there is a connection to C. Okay, then you have to find out the adjacency vertices of each nodes. Okay, so what are the adjacency vertices of A, B? Sorry, for A it's having edge to B, right? And it's also having edge to C. Simple, it's having the link to the next node. Okay, and for B we'll be having for A and D. Next, for D we'll be having B and C, and for C A and D, right? So this is how we are going to represent a graph by using list. Okay, the next one is we are going to represent by using arrays. So array is very simple method. You have to take the head nodes. So it's not necessary to deal with not only for the head nodes. Okay, so you can take through any way. So you can take like A, B, C, D like that, or else you can start from any node. Okay, so that's your choice. Now make an array. So how many nodes are there? 4. A, B, C, D, and find out the adjacent vertices and then make a connection. Okay, simply, definitely it will be having the values, right? So A will be stored at one position, B will be stored at one position. So likewise, there will be having each position for the nodes, right? And we are going to provide a link to the adjacent nodes. Simple. For example, so by using this graph itself, I am going to make one map. Okay, just a memory map. Okay, so these are the addresses available. See how A is stored at position 100 and C is stored at position 250 and B is stored at position 750 and D is stored at position 500. Okay, so these are the addresses of memory location. Okay, see, so from A to there is a connection to for both B and C, right? So there will be connection from A, connection to B, right, and connection to C as well. So what is the address for B? 750 and 250. So there is a connection. Just we are going to provide connection to between this between the vertices. Okay, and for B as well. So there will be 2 nodes. Okay, for C also 2 and D 2. Right. So this is how we are going to represent a graph by using adjacency list. Okay, so it's a second method. Right. So in this video we have seen about what is graph and what are the 2 different types of graphs and what are the 2 representations we are having. Right. So I hope you understood the logics very well, and in coming videos you will see we are having many different categories, right, in graph, and we are having many logics are available, and we will see one by one. And thanks for watching.